So I'm Gopinath Palaniappan, and this session on DNS abuse is going to be handled by me. What exactly is DNS abuse is that using the DNS features to perform attacks, cyber attacks on the cyber surface, and that is what exactly is DNS abuse. So this will be the outline of the session. We'll again briefly recap what is domain name, understand the DNS ecosystem, we'll understand the working of the DNS query, and we'll understand something which is new, dynamic DNS. We'll try to understand dynamic DNS, and then we'll go into the attacks carried out by abusing the DNS. And then two of the main features of DNS abuse are the malicious domain detection and the DGA. And then we'll understand the various dimensions of DNS threat intelligence. And then I'll take you to one of the products which we have developed, which is Rakshak DNS. Yeah, there is a hand raise by someone. Can someone put the message on the window? Right. Okay. And then we have developed a tool called as domain name health server, health measurement. And then we encourage contribution to our research. So that will be the last part. So moving on, what is the domain name? This is a portal which leads us to a resource which is called details.html. So this part of the URL is what is called as the domain name, and this is also called as fully qualified domain name, FQDN they call it in short, I mean technically. So this actually is the domain name. So this is the feature which is the domain name which is identity of a machine on the internet, right? So a machine connected to the internet is identified using this domain name, and after you reach that specific machine, you go a specific resource, and that resource is in this path. This is called the path, and after reaching that machine, you need to go to this path in order to locate the required resource. So this is the domain name which we have seen since the morning. Primary objective of DNS. DNS has several objectives. The primary objective is to provide a domain name and get the IP address from that. The reverse is also possible. You give a IP address and you get the domain name, which is called the reverse lookup. And many of them configure, few of them don't configure for the reverse lookup. Meaning you provide IP, getting the domain name is not necessarily happening each time, because it needs a separate configuration, as one of the participants had put in the chat window asking for reverse lookup. So that was not present. Okay, fine. What is DNS ecosystem? Domain registration. What exactly is DNS ecosystem? Let's understand the working of the DNS ecosystem, the business behind that. DNS ecosystem, the first part, domain registration. Let's say that I'm an registrant and I want to register coe.dnssecurity.in is the domain name which I want to register. So I'm a registrant. I approach the registrars for registering coe.dnssecurity.in. First job the registrar does is that they check for the availability of coe.dnssecurity.in, whether someone else has registered coe.dnssecurity.in in the internet, because there cannot be two resources on internet having the same name. The name has to be unique. So they'll check whether coe.dnssecurity.in is taken away by someone else, or is it available for a new user to use that. So, and if it is available, then they register and allow the user to create a resource on the internet with name coe.dnssecurity.in. So while registering, the registrars make an entry into the registry database. This is the registry database, and there are a few mPanel registrars who have access to this registry database, and they make an entry into the registry database saying that coe.dnssecurity.in is the domain name, and it is going to be hosted at these IP addresses. So that registration will happen into this. So it's like a phone book kind of thing, where a name and the number are mapped to each other. Number meaning the internet protocol address, IP address in this case. So that's the registration which is going to happen here. Now, as a user, I went to the registrar and I asked for coe.dnssecurity.in. Registrar checked for the availability of coe.dnssecurity.in and has registered my domain name into the registry database with this corresponding IP address. So it's now present on the internet. Only thing is that I'll have to create the resource, right? I'll create the resource and host some resource on the coidnsecurity.in, right? Now, a user wants to visit coidnsecurity.in. So resolving a domain name, how does that happen? Uh, so user creates user first visits coidnsecurity.in on the browser, and the client machine visits I mean queries the closest recursive resolver. This we know that we have already seen since morning. It approaches the asking for the IP address of the coDNS right? This IP address, this recursive resolver approaches the name servers, list of name servers. It has a DNS hierarchy which is followed. So it approaches the list of name servers. So these name servers have access to this registry database from where they fetch the IP address and return it. So briefly, this is what is a DNS ecosystem which is driving it. So how does the queries, how do they happen? Like first now we are detailing this part, how does this happen, these three components, how does this happen, steps in resolution of a DNS query, right? A user visits coidnsecurity.in, and every time he visits coidnsecurity.in, it checks for the coidnsecurity.in in the local cache. Every machine, every device on the internet has a local cache. So it checks for the IP address of a domain name in its local cache. If it doesn't, if it finds it there, then it straight away accesses the internet resource, coidnsecurity.in, which is present, okay, which is hosted in somewhere on the internet, and it straight away hits that IP address and accesses that resource corresponding to coidnsecurity.in. If it doesn't have in the local cache, then it approaches the closest recursive resolver. It approaches the closest recursive resolver. Recursive resolver checks for the IP address of coidnsecurity.in in its own cache. If it is present, then it returns from there. It returns the IP address from there, and the requesting client directly connects to the resource. If recursive resolver does not have the entry in the local cache, then it contacts the root and it asks for the .in registry from root. So root returns the name server of .in, and then the recursive resolver calls the asks for coidnsecurity.in from the .in name server, and the .in name server returns the coidnsecurity.in name server's address. Then finally, the recursive resolver contacts the name server which has the coidnsecurity.in IP address, and it returns the IP address of coidnsecurity.in, which is finally returned to the client machine, and client machine finally connects to the recursive resolver. So this is the normal DNS query resolution process, right? So there are three hops. One, it may resolve in the cache itself in the local device, or it may resolve in the cache at the recursive resolver, or it has to traverse the hierarchy. Okay, hierarchy, DNS hierarchy, it has to travel, wherein it has the root, TLD, top level domain, or the second level domain, or it may go to the third level domain also sometimes, depending on the length of the domain name, right? So this is the hierarchy. So right, so this is the normal query. It happens in a normal way. There's a concept of dynamic DNS, wherein if you carefully see this, if you carefully see the previous part, there's a registration into the registry database, meaning the domain name and the IP address are registered into the registry database, meaning that it appears like we cannot be changing the domain name or the IP address very frequently. So because you need to again go through the process in order to update that, right? So there is a concept of dynamic DNS wherein you can change the IP address as frequently as you want. Okay, am I audible now? There's a chat message saying that I'm not audible.
No, you are audible.
Okay, fine. Yeah, thank you. Ma'am, then you'll have to check your speakers. One of them is not able to listen. Okay, fine. Yeah. So right, dynamic DNS is a type of DNS service wherein it allows for dynamic update of IP address of a registered domain, right? So we can change the IP address of a registered domain. Yeah, of course, it comes with a threat, which is called as IP flux, they call it, wherein for a domain name, the IP keeps on changing. That is one of the attacks which many attackers perform. So let's say I have a device which I want to connect to the internet, and it has been assigned a domain name, and I register that domain name with the dynamic DNS provider, DDNS provider, dynamic DNS provider. The domain name is registered, right? So domain name and the IP address are registered. Once it is registered, the on the device we install a small component which is called as a DDNS client, and this DDNS client keeps on monitoring for change of the IP address of this device. Once its IP address changes, it immediately connects with the DNS provider and updates the new IP address into the entry. So it's spontaneous, it's instantaneous, right? So as soon as the device IP address changes, it is immediately updated to the DNS provider. And there's a specific protocol, open protocol, RFC 2136 is the protocol using which this DNS update happens. And there are other mechanisms also, but this is the standard to be followed. RFC 2136 is the standard to be followed for update of a IP address into a DDNS provider. So this is the dynamic DNS. So how do we use it is that we need to start by subscribing to a DNS provider. We need to catch hold of a DNS provider and subscribe to them. Register a domain that is to be used to access the device. Okay, we need to identify a domain and ask for the DNS provider to provide us that domain, register the domain and provide us. Once the registration is done, you install a client, DNS client on the device which you have registered onto the internet for with the domain name. So once you have the DNS client, you add or update the IP address of the DNS of the device onto the DNS provider, and after that, you have the DNS client keeps on monitoring the device for any change in the IP. If there is a change in the IP, it immediately updates the IP of the DNS provider. Otherwise, if there is no change, it again keeps on looping here, checking for the change in the IP, right? So it's a continuous process. So this is the process for a dynamic DNS. There are many DDNS providers: Dyn DNS, No IP, Duck DNS, Cloudflare, DynU, Change IP. All these are DDNS providers. And we can host our own DDNS. Many of the internet people, I mean cyberspace professionals do that. Software available for setting of DDNS are Bind, Power DNS, DNS Mask, NSD, name server daemon, and not DNS. So these are the popularly used software for setting up of DDNS. So that is about the DNS. So we have seen two types of DNS, which is a normal DNS and the other is a dynamic DNS, wherein it allows for dynamic update of IP address of a given domain, of a registered domain. Right. So attacks carried out by abusing DNS. Okay, what are the attacks carried out by abusing DNS? Is that we can have a malware attack carried out. Okay, drive-by download and malware propagation can happen through with the help of DNS. Phishing attack can happen wherein we steal data. So most of the times, most of the times. Okay, fine. We'll come to that question. How can we secure DNS? We are coming to that. Yeah. Phishing is one of the attacks wherein they steal a data. Botnets are widely used. Botnet is again a malware wherein a group of machines are infected and they help connect to a remote device, remote monitoring server. Data exfiltration is also possible. Steal data at a larger scale. Command and control, CNC and botnet happen hand in hand. Many times it is like botnet, data exfiltration, and command and control go hand in hand at the same time, synchronizing with each other to perform a complete attack, and that is called a DNS tunneling. They call it. So these three go hand in hand to perform a attack of that kind. So these are the primary attacks which can be done with the help of DNS. I mean, by abusing DNS. Okay. Malicious domains. What exactly are malicious domains? Are domain names used to perform malicious activities in cyberspace, right? So domain is used to perform malicious activities in cyberspace are malicious domains. They may resemble a genuine or branded domain name also because they want to cheat the internet users. So they may have genuine or branded domain names and mimic branded or genuine domain names. It may appear same, but they may not be the same actually. So what are the threats that are possible using a malicious domain? Or malware distribution. Malware distribution can happen using malicious domains. Command and control domains. Command and control is possible. I mean, you have a client and server architecture wherein infected client connects to a malicious attacker server. So that is what is command and control. They also call it as C2 server. So command and control domains are possible. Data exfiltration is possible. Okay, data exfiltration can happen. Phishing and farming also are possible using this. Okay, right. So malicious domains can be used for any of these purposes. So we have come up with a detection approach for malicious domains. And here is a chart which compares the existing approaches and our approach for detection of malicious domains. Right. So conventional approach is that people have a static blacklisted domain names, whereas we generate dynamic list of blacklist of domain names with the support of artificial intelligence, right? So we continuously monitor and keep on updating the list on the go. And our blacklist is regularly getting updated. So, and the second point is based on blacklist populated through community reporting, right? So many of them use the reporting from the community to generate their blacklist, whereas we have self-learning features from the traffic which is coming to the DNS server. We investigate the traffic and generate our own blacklist based on the features that we extract from a domain name, the traffic features and the domain name features that we extract. We are doing a self-learning based on that. Okay. Okay, fine. There is a question on the chat window which says that, okay, which says running normal DNS is good or DDNS. Okay, fine. So it depends on the requirement. For example, the requirement of DDNS is exactly like we have several IoT devices which connect to the internet, and an IoT device cannot be given a dedicated IP address. They are allocated as and when they connect to the as and when they want to establish a connection. Similarly, we have many webcams which are running at households for monitoring kids at home. So these we have Wi-Fi routers, so they don't have static IP addresses, right? So they don't have static IP addresses. So we need to have them registered, and each time the IP changes, it is again mapped onto the DNS server. So those are the places where DDNS is required. Okay, how to block dynamic DNS records? It's not possible to block actually. So because dynamic DNS and DDNS, there's no difference as far as from a user's perspective. We don't know whether we are connecting to a dynamic DNS or we are connecting to normal DNS is not known. So one cannot be stopping that of because if you see, bind is used to host a normal DNS and it can also be used to host a dynamic DNS. So when I query a resolve DNS server, I may be just able to find out that it is hosted using bind, but one may not be able to differentiate between whether it's a dynamic DNS or a normal DNS. So it's not possible to block that. Fine. So a few and existing approaches reside at firewall and work on a packet analysis. Okay, they are mostly based on packet analysis, and our solution resides on the recursive resolver. It's on the recursive resolver or the internet gateways of a building of a enterprise, right? So and we also have a browser extension which can be used. Others don't have an explicit known algorithm which they use to identify blacklist, whereas we have a self-curated database data set comprising of real-world traffic, and we have learned our artificial intelligence engine has learned from those data which are collected from the real internet traffic. to build a threat intelligence. So we have about 4 million benign domains as of now and 1.2 million malicious domains as of now with us for the learning purpose, and it's growing every day. The research publications have been considering only whois and lexical features, right? Whois feature is nothing but the registrant details and the registrar details of a domain name. There is a protocol by name RDAP, Registration Data Access Protocol, RDAP, which from which using which we can query the whois server and ask for the registrant and registrar details of a domain name. So most of the work is based on these two features, whereas we have categories of various features which we'll explain in the subsequent slide. Cannot detect the malicious domains that are seen for the first time. So because because the existing approaches are based on community reporting, malicious domains which are created for the first time cannot be detected using that unless until they are reported. So there is an AI model which works in the background to identify the malicious domains, and so a new domain can also be categorized as malicious if it is used for a malicious purpose using our algorithm. Right. So we have seen what are malicious domains, and there is a specific category of malicious domains which is nothing but DGA they call it, which are nothing but algorithmically generated domain names. So there is an algorithm which runs in the background and generates a domain name, right? So what earlier was happening was that one of the DNS abuse activities in which traditionally malware used hard-coded domain names or IP addresses of C2 server for command and control, right? If there is a hard-coded domain name or IP addresses, then we can easily reverse engineer and identify the domain name or the IP address which was used for malicious operations, right? And we can track down and blacklist that domain name or the IP address. So nowadays they have started employing DGA, domain generation algorithms, wherein the domain name is generated dynamically at runtime. Okay, when the connection is happening, the domain name is generated and traffic starts flowing to that. So using that, if we have a malware binary, we cannot reverse engineer and identify the domain name which is used for performing the malicious actor because it has the algorithm to generate the domain name, but it does not have the hard-coded actual domain name present in the malware. So it is not possible to identify a DGA using that. Because we cannot identify a domain name or the IP address which is used, shutting down or blacklisting that service becomes difficult for internet service providers, right? So algorithmically generated names are also known as DGAs. DJ helps to keep changing the domain name of C2 server, which is called domain flexing. Okay, I keeping on changing the IP address for a given domain is called IP flexing. Keeping on changing the domain name for a service is called the domain flexing, right? Okay, so DGA is nothing but DGA is a program that adversary, the attacker, embeds in malware binary. Okay, this infected machine is there in which a malware is executing itself. So that malware is capable of generating a new domain name based on some seed value, based on some value on a periodic basis. Okay, using so it can generate a large number of pseudo random domain names for command and control, right? So these, you can carefully see this, these are few domain names which are DGA domains. So you can see that there is not much of an English except for the usage of few numbers or few characters of English in this, right? So there are two types of DGA domains generator. One is time independent, the second is time dependent. If the DGA algorithm considers the time as a parameter for generating a domain name, then it's called time dependent. If it does not consider the time, it generates based on some seed or some key value, then it is called time independent. So these are the two categories of DGA domains generation. So how does a DGA domain algorithm look like? So this is a block diagram representing the reworking of a DJ algorithm, right? So they identify a seed. Seed can be anything, any random string or any big integer, a prime number, large enough, or some huge number, or some random pass phrase can also be a seed, right? So it's a that seed is a shared secret between adversary and malware. Okay, malware is the one program infected program which has infected a device, infected a client, and is residing on that client. And adversary is the person who is operating the malicious server, right? So this seed is shared, is common between the adversary and the malicious actor, right? So both have the same seed value, and this seed value is given as input to the DGA algorithm program, and it generates a pseudo random string. This pseudo random string is appended with a TLD like .com or .org, .xyz or .in or anything of that kind. Okay, it is appended with a TLD, and a usable DGA domain is generated, right? So at given point of time, uh, the domain name generated at the adversary and the malware may match, right? And if it matches, then the connection gets established with the malicious server, right? I mean, it's not necessary that every time it matches, but most of the time it will match because it is programmed in similar way. The program running at the adversary end and program running in the client machine, the malware, is also both are the same program. So they will both have the same seed and they have the same algorithm. And so depending on time, they will try to collaborate or meet with each other by executing in such a way that they generate that specific domain name at that specific point of time, right? Okay. So here we have the user, and here we have the malicious website. User visits malicious link. Okay, user visits the malicious link, malicious website. Malware gets downloaded and installed onto the user's machine. Step one, right? So how does it get downloaded? How does it get installed? Is a different story of supplying a malware into the client machine. So let's assume that he visits a malicious link, and a malware is downloaded onto the user's machine, and the infected malware here at the client machine, malware uses seed for DJ generation. Okay, right? So malware on the user machine uses the seed for DJ generation. It comes with the seed because when the malware was downloaded from the malicious website is operated by the attacker. So when along with the malware, the seed also comes. So malware uses that seed to generate the DJ domain, right? And similarly, on the attacker side, attacker uses seed for generating domain, right? So the attacker also uses the seed for generating the domain, right? So so both these work are done by the installed malware, right? The malware program on the user machine and on the attacker machine. List of algorithmically generated domain names are there, and we have the list of algorithmically generated domain names, right? So both sides we have a list of algorithmically generated domain names, and the malware here starts querying to this list of algorithmically generated domain names. Similarly, the attacker starts registering these domain names onto the CNC server, right? Onto the DNS server, right? So once both these synchronize, the query from this side for a specific domain and the registration from this side, attacker side for a domain, if both these synchronize, then a connection is successfully established and a transaction or exchange happens between those two entities, right? So this is the general flow of a okay, right. So this is what step one, DJ is generated, attacker registers a CNC server with the DGA, and step three, the malware infected bot requests the DNS server for a domain name. So it asks for a domain name, this domain name at time T1, and the response was 1.1.1, some domain, some response, meaning it could successfully connect to that. And at time T2, it has asked for some other domain. It says NX domain, meaning the attacker was not successful in registering the domain at that point of time T2, at the DNS servers, so connection was not established. Similarly, for T3, this domain name was queried and it says non-existent domain again. So meaning again failure on the attacker side to register the domain and make it available. Similarly, as T4, there is again query for another domain. Now this domain has taken the same IP address and hosted itself on that, right? So it is, so in that way, exchange happens. So T1 and T4, we have two instances where connection was established with the malicious actor. Okay. Is DNS response getting below to response? Authoritative server is not an authority of domain. Answer authenticated. Answer authentication is not was not authoritative by server. Okay. I didn't understand this question. I think we'll take it up at the end of this session. There's a chat window question. Okay, fine. We'll take that at the end of the session. Okay. Right. So this is the working of a DGA. There are few detection approaches. One is the manual analysis, because if you see carefully here, if you look at these domain names, you can definitely see that these are not human registered domain names, right? So they have some random set of numbers and alphabets being used to register domain name. Usually, when human does it, there will be some logic in the name that human wants to register, right? So a manual analysis wherein you can identify using reverse engineering. Pattern recognition, you try to identify a pattern, meaning try to identify the algorithm, right? And this is possible if you have the malware binary, you go to the binary, reverse engineer that binary and try to identify from there, right? But it is labor intensive, right? We need to do lot of code analysis, binary analysis to identify that. It's limited to known DJs. Only if you know the DJs, you can identify that. Inability to detect variants. Okay, if there are new variants, we won't be able to detect that, right? Whereas in a machine learning related approach, we can have we can have several features extracted from that. We can perform training on that and we can classify, right? Yeah, of course, but there are possibilities of false positives and adversarial attacks are possible, right? Adversarial attacks on the machine learning algorithm, on the model which is built, that is also possible. Meaning, someone may try to poison the training data. If the training data itself is not proper, then there is a possibility of a misleading output, right? So the machine learning approach is something like this. We have taken the benign, let's say we have a benign request for co-dnsecurity.in coming to the DNS server, and we have an infected bot which asks for a DGA domain. There is a continuous learning which is happening here and which updates the classifier model. As soon as the request comes to the recursive resolver, it verifies with the classifier model whether the domain name which is coming is benign or malicious. So it will check with the classifier model depending on the response of the classifier model. If it reports the domains to malicious, then it drops the malicious domain. It doesn't respond to the request. Whereas if it is benign, then it provides the response, right? So this is this is a live learning model, running model in our recursive resolver here in our premises. So we have done this learning part and we are running a model continuously here in this fashion, right? DNS threat intelligence, what are the parameters of DNS threat intelligence which are to be taken care when we have when we host a DNS, right? So malware detection should be part of threat intelligence. Malware communicates through CNC servers using domain names, right? So malware detection should be part of it. Data exfiltration detection usually happens through DNS tunneling technique and involves CNC and botnets too. Incident response and forensic should be in place. Track back domains and IP addresses and to identify the scope and nature of the work. Right. So what exactly was the purpose and why did they perform an attack should be known, right? Okay. Fine. Protection from phishing, deceptive domains have to be identified. Okay, a blacklist should be present continuously. Updated blacklist should be present for protection from phishing. Botnet detection operate using DG and CNC. Both work using domain names, right? Botnet detections work using DG and CNC. So both operate, of course, on top of domain names, which is a DNS abuse. We need to have a botnet detection in place. Identify domain names used to carry out attack. Okay, DNS domain reputation management. So we should have a continuous score evaluation of the domain name to identify their authenticity and working of that. Blocking malicious domains, IP address, and detection of anomalous DNS traffic, right? So we should have an early and protective threat identification mechanism for that, right? So that is what is DNS threat intelligence. So these are the parameters which should be part of a DNS threat intelligence system for a secure DNS. Right. We have our Rakshak DNS enterprise solution, which can be offered as an enterprise DNS. So we have come up with a recursive resolver which is safe, secure, and it is open DNS. It is resolved. It is present here. We also offer the same thing as a DNS solution also, enterprise DNS solution also. Okay, fine. So. Right. The components of our enterprise Rakshak DNS are these: log analysis. We perform continuous log analysis. We have our Rakshak DNS is performance enhanced. We have a very low round trip time. We provide traffic visualization. We provide domain blacklisting and whitelisting. We have several security enhancements to our recursive resolver, Rakshak DNS. We have done the operating system hardening of the operating system on which we have deployed our hosted our enterprise DNS. So these are the components, right? So Rakshak DNS domain maliciousness detection. These are the roughly these are the parameters. There are actually 62 parameters which we have worked, but these are the parameters on which we have. These are the broad parameters. We take the reputation of a domain based on the history. We perform alphabetical analysis, meaning lexical analysis. We check for global ranking of domain names using a few services. And there are a few services which are not listed here, using those also. We keep record of the registration data, and changes in registration data are monitored. And registration data meaning not only domain name, the IP data also. Who is using the IP and how long they have been using the IP is getting tracked by us. We also ask for web traffic. We have two parts of the web traffic. One is the traffic coming to the recursive resolver. The other is the traffic, internet traffic, usage traffic of a website. And we look at the content and category. Okay, the type of website that it is, whether it's e-commerce website, whether it's an education website, all those are tracked. How many number of pages does it have? How many number of pages do the websites have? Depth of the website. Are there any broken links present in the website? Meaning the links. So let's say that someone is hosting a malicious website, then they'll be simply putting some links which will be leading to 404. There won't be any resource present, but they'll simply putting the links. So such links are called broken links. Fine. So I think I have covered this. So Rakshak DNS, we have hosted our Rakshak DNS at this IP address, and this is the IPv6 address. We have many tools developed as part of the CODNS security.in project, and it is freely available at this portal, CODNS security.in. And we have integrated as part the tool malicious domain detection as a component in Agne. We have a firewall, dynamic firewall being developed, and we have integrated that tool as part of it. We have opened the API service. One can hit this service and ask for it. There's a registration requirement because we cannot be opening this for someone may perform an attack. So there's a registration to be done in order to fetch this API blacklist from this API services. So on a daily basis and weekly basis, we provide blacklisted domain names. So these services can be used to fetch blacklisted domain names. Here is a benchmarking of our Rakshak with other solutions, other DNS providers, which across the globe. So you can see that we have a good threat intelligence model, and we have a local root server residing with us. So this helps us reduce the round trip time to a large extent, and we have the malicious domain detection component integrated into it. We have whitelisting and blacklisting. We have personalized threat intelligence. So when it comes to enterprise DNS, we try to study the traffic which is present in the enterprise, and a personalized threat intelligence is automatically generated by the Rakshak DNS if it is deployed in the premises. We have another component which is called as the domain name server health measurement. So this is about given a domain name, it is scattered by several name servers. How well configured are those name servers so that they can help resolving a given domain name? That is what is this component. So we have several components on which we work to resolve this. We have put up this DNS health tool on our co-dnssecurity.in. So these are the parameters based on which we measure the health of name servers of a given domain name, right? And this is a request to you all to contribute and add the intelligence of our tools. So this is our portal co-dnssecurity.in. In that we have the spam box tab. In that tab we have two parts. One is the report spam email, and the other is this report spam malicious domain or URL. So if you have any suspicion on an email that you receive, you may please forward to spam@co-dnssecurity.in. So it will add. We have email solution also. So it will add to our intelligence to identify spam emails. Similarly, if you have any malicious URL or malicious domain, a domain or URL that you feel suspicious about, you can definitely enter here and submit to us, and it will add to our database for further learning and enhancing uh, our tools intelligence. Right, PPT will be shared, sir. Okay, there is a question. What DNS security features are enabled in Rakshak? Okay, fine. So we have this complete set of features. Rakshak is a dual stack. It is on IPv6 and IPv4. We have Rakshak is DNS sec enabled, so there is no possibility for cache poisoning. DNS cache poisoning is not possible. We have threat intelligence. The threat intelligence which are shown here. Yeah, the threat intelligence which are listed here is present as part of our Rakshak tool. Yeah, of course, malicious domain detection, whitelisting, blacklisting, and personalized threat intelligence are part of this threat intelligence. And we also have a local root server, meaning a request coming to recursive resolver does not visit the root server. We are having a copy of the root server running in our recursive resolver itself. There is a RFC 8806 which using we have implemented that RFC 8806, using which every 30 minutes our recursive resolver connects to the root server and downloads its records. So there is no the request coming to our recursive resolver doesn't go to the that doesn't go to the root server for resolution. So by that we are reducing the round trip time. Right. If someone register a domain name similar to organization name to host fake website, how to take down the domain name? Okay. Okay. There is a question from Mr. Joginder Singh. If someone register a domain name similar to organization name to host fake website, how to take down the domain name of fake website? Okay. Meaning, let's say that I'm from CDAC.in. Right. Okay. The IP address of Rakshak. Yeah. So these are the IP addresses of Rakshak. So you mean to say that someone has registered with CDAC.in, right? CDAC.in is already existing, so no, no one else can register as cdac.in, but of course one can register saying that Center for Development of Advanced Computing.in. This may be possible, but I don't know the character length. Character length, there is a limit to the character length. There are 255 characters, which is the limit. So one may, if Center for Development of Advanced Computing.in does satisfies the length criteria, then one can create that, and someone has to report that to identify the domain name. It's like the question is like, I'm Gopinath and someone else has the same name Gopinath. So how do we identify? It's a similar question. So it's unless until someone reports that, it is difficult to identify that. So you can point your DNS as forwarder to Rakshak DNS. You can do that. Yes, sir. You're welcome. There is a question from IG Car. Okay, Atomic Research Center. Okay. Can you tell us your learning software? What exactly is the question, ma'am? I didn't understand. Learning software meaning? We are using Bind for our DNS server. That's the thing. Is it something else, or is that the question? Right. So this much is from my side. Any other questions? Any queries on DNS or any product, cybersecurity product related queries can be sent to rice@clac.in, or it can also be sent to gopinath@clac.in. And please do visit codnssecurity.in. We have several free tools which are developed as part of this project.